Do you hear me? Okay, yeah. So, hello to everybody. I'm Francesco Latini from the Italian Space Agency, and I'm here talking about this ISRU technological demonstrator for the production of oxygen on the moon that we are developing together with Politecnico of Milan. So we learned a lot this morning and today also now from ISRU. So I'm going to give you a very, very quick overview of, on ISRU and then the mission that we're going to develop for developing it. So I'm not going to go into the details of oxygen extraction and why it is so important for enabling the sustainable and permanent presence of humans on the moon or water, fuel, construction materials, and especially extracting oxygen, which is very important and present in the regolith as main source on the moon. And in particular, this chart was already given this morning, but I just want to stress the fact that, as we already seen, the presence of so different regolith samples have different percentage of metals, minerals, and of course oxygen. And this is important because depending on which process we think about using for extracting oxygen, it may give different yields of extraction. So what presentation in this morning from Polytechnic of Milan was already given, was under an ESA contract in which a plant was already built to process 1 kilogram of lunar regolith together with OHB Italia, and in particular also a customized reactor based on the design, which is in order to verify the possible design for the lunar environment, which was done and is has been done. So what we want to do, taking this idea from Milan, is to develop actually a plant. Okay, so there was, no, that's correct. A plant which you can see here as a whole. And regarding what I already said about the different yield of extraction, the good part about this process is that the yield of extraction does not depend on the regolith that you use. So we can, we can go on whichever mission independently from the landing site that is selected for that particular mission. Also, another interesting point from technological development is that the temperature at which the regolith is heated up is below melting temperature, which is the temperature in the reactor, which is 1100 Celsius degrees, meaning that it allows a simplified architecture for the whole plant because the regolith does not melt, so you don't have to discharge the product in case you want to repeat the experiment more than once. However, this is the whole plant. The idea is now to provide just for the first, the main reactor in which the regolith and the process takes place. I didn't say that, of course, but this is a carbothermal reaction. In fact, Oracle stands for Oxygen Retrieval Asset for Carbothermal Reduction of Lunar Environment. So regolith is processed with CH4 in order to produce carbon oxides. Was already been said this morning, but of course it is important to repeat it. And anyway, we are thinking about developing just the first reactor and considering the second reactor and the condenser as a possible upgrade for the mission. So From the perspective, from the agency perspective, so we need to think about the performances, the architecture, interfaces, and drivers' needs. So on one side, we need to take a look at the launches calendar and understand when we can be able to launch in the time window from 2028, 2029. Of course, the accommodation, so where we are going to put this demonstrator on the lander, so the study of the interfaces, and the landing site, although I'd already told you that it is not so important for us. On the other point of view, of course, we need to take into consideration everything regarding the testing of the plant, and to understand which simulants should be used in order to understand better the process and to, refine it in terms of temperatures and power that it is the duration, for example. And most importantly, maybe is everything related to the sample acquisition from in order to put the regolith inside the process and to allow, for example, a sieve in order to avoid gross grains, large grains to enter the reactor, and everything related to the sample acquisition and maybe a sample analysis in order to correlate the results in terms of oxygen extracted with respect to the composition of the regolith at the beginning. So from an agency point of view, of course, we are interested in the timeline of the whole mission. So we are in 2023 now, and we just finished the negotiation with the scientific partner at the university regarding the developing of the process to enter the next phase, so phase A and B1. We will start we already started, and we will proceed in the identification of the industrial partner by the end of this year, and also the identification of the launcher provider, and we will start the negotiation with industrial partner by the end of this year. Later, we will proceed with, so of course, the mission study phase A and B1 will be in progress in 2024, and the results from that and from the negotiation with the launcher provider will be necessary information for the start of the industrial contract with the industry for all the operations from phase B to phase E. In 2025, there's going to be this activity, and we will end all the phase of the collaborations and the sign of contracts, hopefully. While all this information is going to be while all these processes will the implementation of the launcher provide service will start in 2026. Together with another negotiation for the scientific partner, which will support us for all the other phases. Then in 2027, we expect to sign this other contract and again to implement everything with respect to the payload and the integration and system activities in the frame of the launcher provider service. And in 2028, we foresee to have the qualification and acceptance review and to put in place the service of the payload together with the scientific support for the remaining phases. Finally, the hope is to get ready for launch in 2029, maybe even a little bit earlier, and to have the operation phases on the moon. Just want to point out, and this is crucial for what we're doing, is that everything is fully funded, excluding the launch service. Which are the opportunities that we are foreseeing for the launch? Well, there are many, fortunately. So either we can think about CLIPS, Or we can think about the Artemis program and to get on board one of the opportunities if they arise, either with a commercial provider, which would be nice, of course, or to cooperate with international partners and to follow on that path. So thank you very much for the attention. And if you have any questions,